Hi, I am Dr. Eli Kohlberg from Unlimited Robotics, and in this video I will talk about electric energy and power. We recall that the electric voltage forces the electric current to flow through a resistance. In order to overcome that resistance, an electric energy is invested. Electric energy is in fact the ability to perform electric work like creating lighting or operate an electric motor. The electric energy is marked with the letter W. As the voltage source V supplies more voltage to the load, the higher energy the load consumes. The electric energy is in direct proportion to the voltage V. In addition, the larger Q charge the power supply supplies to the load, the higher energy the load consumes. The electric energy is in direct proportion to the charge Q. In summary, the electric energy is in direct proportion to the voltage V and to the charge Q. The electric energy mark is the letter W. That brings to the next equation. W equals V times Q. We already mentioned that the amount of electric charge is equal to the amount of current that flows in a certain time. It means that Q equals I times T. We will substitute last expression for Q in the equation for W and get W equals V times Q, which is equal to V times I times T, where W is energy in units of joule, V is voltage in units of volt, I is the amount of current in units of ampere, and T is the time in units of seconds. The electric energy invested in the load is in direct proportion with the voltage supplied to the load to the intensity of the current that flows through the load and the period of time that the current flows. The unit of electric energy is joule and is marked by the letter J. 1 joule is the energy invested in a load when a 1 volt voltage causes a current of 1 ampere to flow through the load for a time period of 1 second. Example: calculate the energy consumed by a load that is connected to a voltage source of 10 volts for 5 seconds and the amount of current that flows through the load is 4 amperes. Answer: we will use the last equation, W equals V times I times T, which in this case is 10 volts times 4 amperes times 5 seconds, that gives 200 joules. Electric power expresses the energy invested in a load during a time unit. The electric power is marked by the letter P. Thus, we can express electric power as energy over time. P equals W divided by T, which is equal to V times I times T equals by T, that is reduced to V times I. That is to say that the electrical power consumed by a load is equal to the product of the voltage supplied to the load by the current that flows through the load. The power unit is watt and is designated by the letter W. 1 watt is the power invested in a load when a voltage of 1 volt forces a current of 1 ampere to flow through the load. As we already encountered, the equation for calculating the electric power is P equals V times I, where P is the power in units of watts, V is the voltage in units of volts, and I is the current in units of amperes. Similar to Ohm's law, we can present the equation for calculating the electric power in a graphic way. It is easy to see from the graphic here that P equals V times I, V equals P divided by I, and I is equal to P divided by V. Example: calculate the power invested in a load that is fed from 12 volt voltage source when the current that flows through it is a quarter of ampere. Answer: we will substitute the data in the equation. P equals V times I, which is equal to 12 volts times 0.25 amperes. That gives 3 watts. From Ohm's law, V equals I times R, and I equals V over R. Substituting the equation for voltage and current in the power equation will yield P equals V times I, which equals to I times R, this is V, times I. And in total it gives us I squared times R. The second equation, P equals V times I, which equals to V times V divided by R, this is I, which gives in total V squared divided by R. We see that the power is in direct proportion to the squared voltage and is in direct proportion to the squared current. It means that if the voltage will be doubled, the consumed power will be increased by 4. In a similar way, if the current will be doubled, the consumed power will be increased by 4. We recall that the electric energy is W equals V times I times T. Substituting P equals V times I in the equation for electric power will give W equals V times I times T, which is equal to P times T, where W is energy in units of joules, P is the power in units of watts, and T is time units in seconds. Sometimes it is more convenient to use unit like kilowatts. 1 kilowatt equals to 1000 watts. Energy unit joule, J, is sometimes expressed as watts per second, WS. More customary unit for energy is kilowatt per hour, kWh. Example: calculate the energy consumed by a motor with a power of 200 watts that operates for 2 hours. Answer: 2 hours equal to 2 hours times 60 minutes per hour times 60 seconds per minute, which gives 7,200 seconds. W equals P times T, which in this case equals 200 watts times 7,200 seconds, which gives us 1,44,000 joules. If we use kilowatt hours unit, it will yield W equals P times T, which equals to 0.2 kilowatt times 2 hours, and this gives us 0.4 kilowatt hour. Pay attention that the 0.2 kilowatts equal to 200 watts. The power cycle is presented in the next figure, and each quarter is designed for different component. We can see in the upper left side the power, the lower left side is the current, the higher right side is for voltage, and the lower right side is for resistance. That's all for now. Thank you for being with me. Hope to see you in the next lecture. Bye bye.